Hello and welcome to this talk at SUSECON Digital 21 about large-scale Kubernetes deployments on the edge with Open Nebula, Rancher, and K3s. Howdy, this is our agenda for today. First, we focus on the challenge and motivation behind the solution. We will hand over to describing the use cases, the need and the demands for such a solution. Then we will focus on the solution overview, give you a brief introduction of the solution we built. And last but not least, in the end, we will finishing this talk with a live demonstration and showcase of this solution. But first, let's introduce the people behind this solution.
Okay, thanks, Sebastian. My name is Marco Mancini, and I work at Open Nebula. That is a company based in Madrid that focuses on open source solutions for cloud and edge computing. I work remotely from Italy, Lecce, and as a cloud technical evangelist. So my main role is to engage with the community, to participate to events like the SUSECON or webinars or other events where I talk and showcase open source technologies, related to clouds, containers, Kubernetes, and so on. Okay, let's, Philip, you can introduce yourself. Okay.
My name is Philip Kainz. I'm CVO and co-founder of SUSECON. We are focused on modernize your applications with application performance monitoring and bring your Kubernetes cluster in your company.
Thank you, Philip. Hi, I'm Sebastian. I'm CEO and co-founder of FullStacks together with Philip. And as Philip mentioned before, we are focusing on your business. We try and our aim, our goal is to enable our customers by understanding their business, allowing us to build up the IT infrastructure we need to let your business run optimal. And this is one reason because we have invented and crafted such a solution like we describe it today in this talk. But first, let's talk about the challenge and the motivation for this solution. Why we have developed such a solution. From our perspective, Kubernetes is the operating system of innovation. Kubernetes is to compute what the IP protocol is for the internet. It's a uniform standard in the edge, in the core, and in the cloud. And compute allows you to enable and live innovation. The question is, do we need to run Kubernetes everywhere? Yep, this is exactly the requirement. And this is exactly what makes innovation possible everywhere. We can deal with our resource providers in the edge, in the core, and in the cloud, abstract them, allowing us to run our innovation based on compute everywhere. And this is exactly focusing to the use case why and for what such a solution. And this is a part for you, Philip, to focus and give us more details on the use case.
Yeah, there are lots of use cases, Sebastian. You can run services, for example, for sure in the core, in the cloud, and now you can run services in the edge. You can run services, for example, in the edge, in the public sector, in IoT, in 5G networks, and so on, in retail and hospitality, or in branches. And therefore, you need a management platform. You need a Kubernetes management platform. You have one overview over all your clusters. You have your clusters in the cloud, for example, in the Azure or AWS or on-prem in the Cure. And therefore, you need a management platform. You have to run different container technologies, RKE1 or 2, in core and in the cloud. And in the edge, you need a small packet. And therefore, we use K3s. So, Sebastian, let's go on.
But I have a question. I think we need to take a closer look on the edge, because from my understanding, edge does not equal edge. We have to separate things there in the edge, right, Philip?
Yeah, there's a real big difference between near edge and far edge. You have the connection problems, you have low latency, and so on. The near edge, for example, in a remote branch, you have a connection, you have a good connection. And in the far edge, for example, in a transport sector, in a train, for example, you have a good connection, you have a bad connection, you have low latency, you have a good latency, and therefore you need a solution to run your services. For example, an app, an Schnitzel app, to order some things or order some beer, and therefore you need a solution.
Okay, so the challenge is regarding the infrastructure. In the near edge, we are talking about HCI solutions or edge cloud providers, allowing you to run your edge computing infrastructure. And in the far edge, in the real edge, from our perspective, the challenge is named device. We have to deal with devices, right? So if we took a closer look on the challenges we have spotted in the edge computing, they are very simple. They sound like commodity, but there are no easy solutions for it. It starts with basic provisioning and setup, bringing a usable operating system on the device, setting up Kubernetes, doing the lifecycle management, orchestrate the workloads, monitor the devices, do a fleet-based management. And last but not least, the solution has to be robust and it has to be automated. And that's why we've built this solution, allowing you to set up any device in the edge, allowing you to do computing, setting up Kubernetes clusters in an automated manner. And these Kubernetes clusters do an auto-registering of themselves in the central rancher management cluster. From our perspective, this is a perfect combination of all ecosystems consisting of OPN Nebula, Rancher, CAS, and last but not least, the underlying Linux operating system. But Philip, I think you can give us a closer look and a brief explanation how this solution looks like.
There we have the solution. There are different stacks, and you can see the near edge and the far edge. It's the same. It's the same solution. We have the devices, we have the HCI solutions, the edge cloud providers, and so on. And therefore, we need an automation. And there, OpenNebula comes in place. Later on, Marco will explain in detail how OpenNebula works. And then the next stack, we need the Rancher Kubernetes management platform, where all your clusters will be managed. You have there, for example, the fleet management to deploy on your different edge, near and far edge workloads from any place. And therefore, you have to choose the right Kubernetes platform. We choose Rancher K3S. It's very robust, it's small, and it's run every time, everywhere in the near edge and in the far edge.
With the solution overview, this is part for Marco explaining us OPN Nebula. What is OPN Nebula, Marco?
Okay. What is Open Nebula? So Open Nebula is an open source solution to build enterprise cloud computing solution. Okay, so Open Nebula started as an on-premise solution, just for your bare metal, your servers on-premise. Now with the latest release that we released a few weeks ago, the 6.0, really Open Nebula is now a solution that allow companies to implement multi-cloud, hybrid, and edge computing. So it's a solution for that goes on the continuum, as you said, from the on-premise until the near edge and the far edge. So Open Nebula at the moment is so it's like a uniform layer that allows you to automate your infrastructure that is on-premise or on the edge, hosted on public cloud and so on, where you can run different kind of workloads. So now we deal with virtual machines. So we support different kind of hypervisor, KVM, LXC, VMware, but you can run also other type of workloads. So application containers and Kubernetes cluster that now is needed for the solution that we are describing in this talk. So we support both the Kubernetes distribution, the K3S, also lightweight distribution, no? That is specially designed and for the edge, right? So regarding the edge computing, so we can go on the next slide. So with the latest release of Open Nebula, we now have this new tool that is called Fire Edge. So with this tool, you can provision Open Nebula clusters that are, as I said, could be on premise, could be on the near edge, could be on public clouds like AWS or Equinix Metal, could be on far edge. We have just recently released also this on-premise provider plugin. Okay, so we can configure Open Nebula cluster, and then you can configure these clusters by using different technologies that we support. So from KVM to Firecracker. So we can also deploy Firecracker micro VMs. Especially this is useful, especially for example for the edge. Once we deploy with this tool other resources, and then you can manage these resources by using one uniform interface. That is, for example, you can use the graphical user interface that is called the Sandstone in Open Nebula. Then you can deploy applications, workloads on these resources. Now we have the concept of the marketplace. So we have extended this marketplace to also Docker Hub and so also for container-based applications. And we have different appliances that you can deploy. So in this solution, as you can see, we can first deploy resources on the edge and configure in order to be managed by Open Nebula. And then you can deploy, for example, the K3S clusters on these resources. And as you said already, then these clusters will auto-register to a rancher deployment data. So this is just to give an overview what you can enable by using Open Nebula for the solution that you are describing.
So if we look a bit deeper on the solution, giving you a brief description of the theme of this edge computing solution, we can use and leverage Open Nebula for building up a virtual edge computing infrastructure as a service layer, which allows you to do compute everywhere. And Open Nebula has way more features than only provision the infrastructure. There are many moving parts inside it, allowing you to do an automation inside the virtual machine, the micro VM, or even the container called contextualization. And there is also a key value store available and an automation engine, one flow, one service, and many, many more tools. And we have combined these tools together, allowing you to form your custom edge computing private cloud based on Open Nebula, Rancher, and K3S. And if we dig a bit deeper, we can see the architecture of this solution. On the left side, in the green box, we see Open Nebula. In the blue box on the right side, we can see the Rancher management cluster. And first, we try to create a new edge computing cluster, either via API or user interface. Also, the use of infrastructure as code, for example, with Terraform is able and possible. We call Open Nebula build up a new piece, a new unit of computing. Deploy this to the edge, for example, on a device, as we mentioned before, with the Firecracker hypervisor. The VM spins up, boots, gets its configuration like hostname, IP addresses, username, passwords, all the credentials directly from Open Nebula via the integrated key and value store called OneGate, which allows us to set, retrieve, and update those keys value paths via REST API calls. And in the end, we are able to automate the complete setup of the K3S cluster, single node and multi-node, and handing over those newly built Kubernetes edge clusters for self-registration to the central Rancher management cluster. And in the end, this solution allows you to do a fleet-based management with a component called Fleet inside of Rancher and orchestrating your workloads, monitor them, make them visible, make them deployable on your groups of clusters. And this setup scales up to thousands or even millions of Kubernetes clusters. And that's exactly what we now showed to you in our live demonstration. Let's set up an edge Kubernetes cluster together with Nebula, with Rancher, with K3s, and the glue behind it, the solution we have built together, Nebula together with FullStacks. So I would say it's demo time. Thank you for listening to this talk. And if there are any questions, on the first slide where we introduce the peoples, there are our contact details and contact informations. We are really looking forward to getting in touch with you. Enjoy the live demonstration. Thank you.
Okay, so let's start with the demo. We have already deployed an Nebula cloud. You can see on the left, this is the dashboard of the Sandstone graphical user interface. And we have also a Ranger deployment. You can see on the right, the user interface. There are no clusters at the moment defined. Also in the Nebula cloud, we are already provisioned a cluster. This one cluster that we call edge cluster with the one host, public net, and the data stores for images and micro VM. And this has been provisioned by using the FireEdge user interface. You can see here we have provisioned this edge cluster on the Equinix Metal. Also, the FireEdge interface, you can see you have the dashboard of the cluster that you have provisioned, and you can define also the providers. So now, for example, in this case, Equinix Metal, but you can define other providers for AWS and so on. The first step in order to deploy a K3s clusters in an Nebula is to import the K3s service appliance. You can search for the service by looking in the apps tab and looking for this service K3s for Firecracker. And then you can import on your Nebula cloud. I already imported the service. So what we are going to do now is just instantiate the service and create a cluster. Okay. So here you can put the name of the cluster. You have to specify the cluster, the Nebula cluster name, where you would like to deploy it. So we have only one, so we just specify the name of the cluster. You can also choose the version of K3s if you want to enable or disable some of the features like DNS, the ingress, load balancer. Now, for the auto registration, we need to pass some information about the Rancher deployment. So we have to pass the URL. And then we have to pass the API key and the secret key. So let's create one. And let's copy the API key and the secret key. Okay. And now we can create the service, and that's now Nebula OneFlow is going to deploy the K3s cluster. And now this service contains two roles. One is the server, the other is the agent. So it's going first to be deployed as a server. So this will boot up the component server of K3s. Then you will generate a token. Then this token will be put on the OneGate metadata server of Nebula. And also when the K3s server is up, this component of OneFlow will change its state to ready. And then OneFlow will know that it can deploy the agent. As you can see, there is a dependency on the server. So when the server is ready, OneFlow will deploy the agent that will join the K3s cluster. Okay, now let's move also the view of Ranger to the clusters. They're still not defined. This will take a few moments for the boot. Okay, now the server is running. You can see also that is auto-registered to Ranger, and the agent is in deploying state. So now also the agent will boot, and we will see here in few moments also the server, the cluster active within the Ranger user interface. Okay, now this is in the waiting state. So in a few moments it should be active. So here we have two nodes, and the two nodes are the server and the agent. Now we can click on the server here on the cluster. And for example, we can just use the cluster explorer, and then you can deploy your applications by using Ranger. Okay, thanks to all. This is the demo, and thanks for attending our talk.